All right, this is the Newton's second law laboratory tutorial. In here, you're gonna learn how to perform the simulation. This lab is actually a lab where you have to use an online simulator to analyze the relationship between force and mass and to calculate the acceleration in 3 different trials. Now, you're gonna be able to change the mass of this hover mass. You're gonna be able to change the strength of the force, and you're gonna be able to calculate the acceleration theoretically with those values. Keep in mind that you're gonna have to do some unit transformations here from grams to kilograms, get the forces in newtons to get the right value of acceleration in meters per second squared. And then you're gonna have to do a few plots, position versus time and velocity versus time. The velocity versus time graph will be used to find the experimental acceleration, which then you will use to do comparisons and then to answer the questions at the end of the lab. So pretty much what you do is you open this simulator. You can change the value of this mass. It's all in 1,000 grams. So you can change the value of the force here. Let's say I put 3.8 and 2,700, like 2,750 grams. That's 2.75 kilograms. You start a simulation and then you find the graphs here, which you are not entirely going to use. Like you can see them here, but I want you guys to use the raw data. Okay. Now, if you have the force and the mass, in here, you need to write the weight of the object, which will be 2.75 kilograms times 9.8. That's the weight of the object. That's what was here in newtons. The force is 3.8 newtons. That will go here. And then the acceleration, careful, is the force divided by 2.75. Is force divided by mass, not weight. Okay, so be careful with that. Then you will have here the acceleration of 1.38 meters per second squared. So that's your first trial. And in the lab, it says that you can do different values of mass, three different values of mass, 3 different values of force. So you want to play with this a little bit. Reduce this. And then you still have your acceleration there. All right. Okay. So how are you going to use the raw data? For the raw data, you have to use Excel. You can use Google Sheets, but let me show you what you're going to do in Excel to calculate the experimental acceleration. So you are going to copy all this table here. And it's already given to you, so you can, like, the columns are already separated with the right units. So it's pretty useful to do that. Keep the number of sig figs in there. And obviously, at the beginning, for a very short amount of time, the position and the velocity are 0. At the instant that it starts moving, then you start seeing a change in the position and the velocity. So if you want to plot position versus time, you just highlight these 2 columns. And then you use a scatter plot, and you will have the same plot that we were giving in the software. Remember, you want to add the axis titles. And then you may want to use, not a line, but you want to use like a polynomial. Let me see what happened here. Ah. There. So we display equation on chart. We eliminate this, and that's your curve there. Very accurate. Position versus time for the first trial. What about the velocity versus time? So time is here, velocity is here. You could use all the data, which should be fine. And then you're going to make sure you select these two columns. See what I'm doing? You can do that by pressing Control, by the way. All right, so we have the velocity versus time graph, but the issue here is this section of points. If you do a trend line, it's going to be messed up. So what you are going to do then is you are going to just plot from the moment you start getting values of velocity. All right, so you're going to plot all these points and all these points here. You may want to do the same for the position versus time, and that's much better. Because what's going to happen now is you are going to do that trend line. And look, we get 1.246, 1.25 meters per. That is low, is the acceleration, because velocity over time is acceleration. So 1.25 meters per second squared. So you want to write here that the experimental acceleration is 1.25 meters per second squared. All right, that's what you want to write here. So what's my theoretical then? I will go back to the software and then look at the values, 2.1 and 1.75. To go from grams to kilograms, I divide by 1,000. That's why. So 2.1 divided by 1.75, 1.2. So my theoretical is 1.20 meters per second square. So the only thing left now is to do the comparison. So the percentage difference, you can do it in Excel, is 2 minus 1.25 divided by 1.2 all times 100%. And I get this percentage difference, 4.16, 4.17 percentage difference. You will do that for each trial. And that's it. Once you have that, you can just go and answer the questions at the end of the lab manual. So again, this is another lab where you have to do some plots and some graphs. The simulator is very easy to use. So you may have questions about the graphing. It might not work the same on Google Spreadsheet. So remember, try to use Excel. If you have issues with that, please send me an email. And as I said at the beginning of the course, the best way to do this lab is to give it yourself enough time. And send me an email, check for my announcements for any online office hours or help. Other than that, have a good day, and then we'll see you in the next lab tutorial.